Good morning. In this lecture, we are going to see about the coordination compounds. In this coordination compounds, we are going to see about the introduction to the coordination chemistry and the terms which can be involved in the coordination chemistry, and also the different types of the complex compounds can be seen under the respective unit, and we can also be seen how we are going to know about the different IPS in nomenclature of coordination chemistry in which the coordination complexes. First, we are going to see with the introduction. That is, what do you mean by the coordination compounds? Before that one, the coordination, the compounds which are also be known as the complexes, means the complexes with the coordination compounds are also be known as the complexes. The complexes are the molecules that possess a metal center, that is, which can be bound with respect to the ligands, atoms, or ions or molecules that donate electrons to the metal. These complexes can be a neutral, means the coordination compounds which can be consist of, means the chemical compounds which consists of it, the respective complexes can be a neutral molecules, means which can be bounded to the central atom via respective coordinate covalent bond. Okay, the coordination chemistry, which means the coordination compounds which consists of the complex compounds, and the coordination chemistry which can be the emerged from the work of Alfred Werner, a Swiss chemist who examined the different compounds composed of the respective cobalt, chloride, and the ammonia upon the addition of hydrochloric acid. Okay, here the coordination chemistry which can be emerged from the respective Alfred Werner, and the resulting observation can be suggested formation of a complex or coordination compounds in the respective inner coordination sphere, which is also be referred in the same text. The first sphere ligands are directly bounded to the central metal in outer coordination sphere, sometimes referred as a second sphere. Okay, in this we can going to be seen, means there may be some of the properties is also be known through the respective coordination compounds. The coordination compounds which can also be referred as the coordination complexes, means the molecules or ions which can bond it to the central atom, which can also be known as the ligands. Okay, the many coordination compounds contain a metallic element as a central atom, therefore referred to as a metal complexes. The types of the coordination complexes, means the coordination compounds are mixed of in the respective stoichiometric compounds. There may be the two types of addition compounds can also be seen under the coordination compound. That is, one is the double salts and another is the complex salts. What do you mean by the double salts as well as complex salts? The compounds formed by the combination of two or more stable chemical compounds, means the compound which must be the more stable and which can loses their identity, means there may be which can loses in the identity in the when we can going to put it in the solution, means they may going to be dissolved, or which can be retained, means which loses its identity. That can be the double salts. There are examples for the double salts, which is carnallite as well as potash alarm. And some things, the coordination compounds, means there may be a different types of coordination complex that generally consists of a transition elements, that is central atom. And it can be noted that the central atom in these complexes, which can also be called as the coordination center. Now, coming to the pictorial representation, where exactly the coordination chemistry means this is the chemistry of coordination compounds, means there may be a formation of chemistry of complex ions. Okay, here coming to the nickel chloride, which undergo hydrolysis, there may be a formation of hexaquo nickel 2, and further undergo chlorination, there may be a reacting with the ammonia, there may be a formation of the respective hexaamino nickel 2, means here the liberation of chlorine. From this pictorial representation, how the addition of the compounds there may be the respective the formation of complex. Okay, and from this we are going to be forming the respective neutral compounds. From this, the neutral compounds can be exist in the formation of the respective complex compounds. Coming to some important terms involving in the coordination compounds, there may be the some of definitions can be followed under different the chemistry of the coordination compounds. Okay, coming to the coordination entity means what do you mean by coordination entity? These are the simple terms, important terms which can be appeared in the coordination compounds. The compound in which the central ion or atom means there may be the coordination center which can be bound to a set of number of atoms or molecules ions is called as coordination entity. Such as there may be a cobalt chloride means there may be a amine is the neutral ligand here, and there may be the cyano. This is also one more complex here, which is nothing but this is the metal ion, this is the transition element, and there may be a consists of a cyano means cyano is the ligand, and here also similarly amino which is nothing but which consists of the ligand, and the cobalt is the metal ion, and the chloride is the anion. Okay, like this. Coming to the central atoms and central ions, what do you mean by the central atoms, central ions? Means there may be atoms or ions, there may be a set of atoms or molecules or ions both referred to a central atoms and the central ions. Okay, here which is nothing but central atoms, which is nothing but a number of set of atoms or ions which can be bounded to a central atom, which is called as the respective central ions. In the coordination compound, there may be a central atoms or ions, typically Lewis acids, and there may be a which can act as the electron pair acceptors. And coming to the one more, the ligand. This is the ligand. We can going to be seen the respective ligands can be observed, and different types of the ligands also be. We can going to classify the ligands on the basis of the donor atoms. First of all, the ligands. Ligands are the atoms or molecules, ions that are bound to the coordination center or central atom, which can be referred as the ligands. And the ligands are either a simple means there may be we can also be defined the ligands as ions or molecules in which donate a least pair of electron to the central metal atom or ion to form a coordinate bond are called ligands. Okay, the ligands are we can going to be classify the different types of ligands. Okay, and there may be the classification of ligands based upon the means there may be a simple molecule or the relatively large molecules. Based on these things we can going to classify the ligands. Okay, once again the ligands are the ion molecules which donate a pair of electron to the central metal atom to form a coordinate bond or called ligands. Okay, similarly the coordination number. Here the coordination number which is nothing but the central atom means there may be a central atom which can also be known as there may be the number of coordinate bonds between the ligands and the central metal atom or ion in the complex is called as the coordination number. Okay, here for example you can going to be seen the coordination complex given by the respective the amino is the respective ligand here, nickel is the central and the metal ion, and this is the respective the coordination number means this is the oxidation number, this is the coordination the number of the respective nickel is 4. Coming to the coordination sphere. What do you mean by the sphere, which is also be known as coordination entity? Okay, entity which is nothing but there may be the coordination entity, the central metal atom or ion which can together with the molecules or ions which can be coordinated to its the respective is called as the coordination sphere, and also be which can also be the neighboring atoms or groups which can be closed in the square bracket. Okay, the coordination center, that is the ligands attached to the coordination center, which can be we can write the coordination sphere. And where exactly the coordination sphere is usually accompanied by a counter ion, and there may be the ionizable groups that can attach to the charged coordination complexes, where exactly there may be the coordination sphere, which is nothing but we can going to be seen in the bracket. Okay, this is the example. Okay, and similarly the coordination polyhedron. What do you mean by coordination polyhedron? The coordination means there may be a geometrical shape by the attachment of the ligands to the respective coordination center is called as coordination polyhedron. For example, such examples are there may be a based upon the ligands attached to the coordination center. There may be a 2, 4, 2, 3, 4, 5, 6, 7 up to 8. Okay, there may be the respective examples spatial arrangements in coordination compounds includes tetrahedral and square planar. Okay, spatial arrangements, that is the coordination number 4. They exist both the symmetry means the different types means tetrahedral and square planar. Next, move on to the next slide. This is the pictorial representation of the respective the coordination complex or coordination compound. Okay, here come to this is the cobalt, where exactly acting as a transition element and which can be the respective metal ion. This amino is the ligand, and which can be the 6 the coordinated with the cobalt. There may be 6 ligands can be attached to the cobalt. Okay, this is the coordination number of this is coordination number of the respective the complex, and where exactly 3Cl minus. Cl minus is the simple anion which can be bonded with the respective the coordination compound, and 3 plus is the oxidation number of the respective coordination compound. Okay, totally we can going to call it as the coordination sphere. This is the spheres which can be in the brackets. Okay, this totally you can going to call it as the complex ion. Okay, next move on to the oxidation number. What do you mean by oxidation number? We can going to be called the oxidation number, which is nothing the central metal atom of the can be calculated, means finding the charge where exactly which can going to be means here we can going to take the example of hexachloroplatinum 2. Here there may be 6 anions present on the chloride. Okay, there may be 2 minus is the respective, and there may be 2 minus, there may be a platinum having a plus 2, means plus 2 minus 2 get neutralized. Totally that is plus 4 is the respective oxidation. Okay, here 6 plus 6, 6 plus 2 means there may be a minus 6 and plus 2 means we can going to be 6 minus 2 is the 4, means where exactly the 4 is the respective oxidation of the platinum atom. Let's move on to the homoleptic and heteroleptic complex. What do you mean by homoleptic and heteroleptic complex? Where the coordination center which can be bonded with the respective type of electronic pair donating ligand. Donating means donation means ligand group. The coordination complex which can be a homoleptic. It can be we can going to be seen. There may be only one type of the electron donating ligand group. Okay, here only one type of donating group. Here where exactly only one ligand is present. Coming to the respective, there may be the heteroleptic, different types of the ligands. Okay, here also chlorine which can also be ligand, chloro which is nothing but and amino. There may be 2 types of the respective ligands can be possible. Okay, the chloro, which is nothing but a, that is negative ligand. We can also be known as, there may be a, the chlorine is the donor atom, and based on the different types of ligands, these are the two types of the ligands. Okay, like this, some of the simple terms which can be explained in the coordination chemistry. Next, we can move on to the general properties of the coordination compounds. What are the general properties? Means the coordination compounds which can be formed by the transition elements are colored due to the presence of unpaired electrons. Means unpaired electrons means there may be a, the plausible, the form of the electrons which can be in unpaired, means there may be a single electron will be present in the different shells. And also this type of the coordination compounds which can observe electronic transition, light electronic transitions. And the example, the complexes containing a iron which can exhibit green, pale green, pale green. Okay, the coordinate compounds containing a iron which can have a yellowish brown color. Okay, like this, the similar the coordination compounds which exhibits the different types of the colors. And also the coordination compounds have a magnetic nature due to the presence of unpaired electrons. Next, we can move on to the similar type of the properties which can also be exhibits. The coordination compounds exhibits a variety of chemical reactivity. There may be the part of inner sphere electron transfer reactions as well as the outer sphere electron transfers. Means there may be existing of a inner sphere electron transfer as well as outer sphere electron transfers. Okay, and similarly certain ligands have the ability aid in the form of, means the transformation of the molecules in the catalytic or stoichiometric manner. Okay, these are some of the properties of the coordination compounds. And similarly the double salts and the coordination compounds means where exactly the formation of double salts, which is nothing but they can be completely ionizable in aqueous solution, and each ion in the solution gives the respective corresponding confirmatory test. Okay, here the double salts means the mixing of, means the non completely ionizable in aqueous solution. Okay, which can use the double salts. The potassium alum is the respective examples for the double salt, and cornellite and more salt. Okay, like this double salts can be exits. Coming to the coordination complex, where exactly coordinate complex are completely ionizable and in aqueous solutions, and there may be they give a complex ion which does not show complete ionization. Means in case of double salts, there may be which can undergo the complex ion which can be complete ionization. It takes place in the respective double salts. Okay, but in case of the double salts, there may be that gives the corresponding confirmatory test. Okay, and the some of the examples of coordination complexes: potassium ferrocyanide and the respective potassium and the ferrocyanide ions, which it ionizes to give the potassium and iron cyanide. Means there may be a complete ionization takes place in case of coordination complex. In case of double salts, there may be there may complete ionization will not be possible in case of double salts. That is the difference. Next, similarly, we can move on to the types of coordination complexes. First one is the cationic complexes, anionic complexes, neutral complexes, homoleptic, heteroleptic, mononuclear, polynuclear. Here, in case of the coordination sphere in the cationic complex is the respective, the coordination sphere is a cation, which can be the cation will be the respective the coordination sphere. Totally, we can going to be seen the coordination sphere which can be the cation is the, means the cation which can going to be seen. Okay, and similarly we can move on to the, means we can move on to the respective anionic complexes. Okay, there may be the anion, which is nothing but the anion which is present in the coordination sphere. And the neutral complexes. Neutral complexes, the coordination sphere, neither cation or anion. Okay. And homoleptic, there may be consists of similar type of ligands which can be plausible in case of homoleptic. Heteroleptic, there may be a different types of ligands. Hetero means there may be two types of ligands can be observed in case of heteroleptic complexes. And mononuclear complexes, which can be there may be the coordination sphere as a single transition metal ion, means single transition metal ion can be observed in case of mononuclear complexes. And the polynuclear complexes, there may be more than one transition metal which can be present, that is the ruthenium, which can be respectively bonded with the chloride ligands. Okay, this is the metal ions. This is the respective complex. Like this, the different types of the coordination complexes can be observed. Next, move on to the. Similarly, we are already the coordination complexes. Okay, how the arrangement of the complexes. There may be the complex we are going to be seen. There may be a group of molecules or the ions which can be a metal complexes. When it is charged with the which can be a complex ion. Next, the complex compounds containing a complexes are known as the coordination compound. Here you can going to be seen cobalt is the respective metal ion and the chloride which can be the negative ligand. And similarly, this is also one type of ligand and which can be bonded with the similar type of the respective ligands which can be attached with the metal ion. And which can also be known as the respective the complexes can be observed in like this, which can also be totally we can going to call it as the metal complex. And the complexes which can also be known as the in case of the coordinating with the respective metal. Okay, here NH3 which is nothing but the ligands. This is OH2 means water. This is the chloride. This is cyano means there may be a lone pair of electrons which can interact with the respective metals. These are the some of the types of different types of the ligands. And what do you mean by you can going to be observed in case of metal and the ligand? What is the coordination? Means the why you can going to be seen. This is a pictorial representation where exactly when an orbital from a ligand with a lone pairs in it overlaps with the empty orbital from a metal, means metal which can be interact with the ligand. Okay, there may be the ligands must have a lone pair of electrons. Coming to the metal ligand band. Here the bond is formed between the Lewis acid and the Lewis base, and the ligands having a non-bonding electrons and the metal has empty orbitals. Similarly, we can going to be seen the Ag plus silver. There may be a reacting with the ammonia and the formation of there may be two equivalents of the ammonia and the where exactly the metal ion means the argentinium which can be attached with the respective coordination sphere. Okay, this bond we can going to be called as the metal ligand bond. Okay, where exactly this is the metal and this is the ligand. Where exactly bonded with in case of metal ligand bond. Okay, this is the some pictorial representation where exactly metal ligand bond can be observed. In the metals coordination ligands, geometry can be greatly alter its properties, such as in case of color and in case of oxidation. We can going to be seen the yellow color and the red color. And coming to the oxidation numbers, where exactly there may be copper which is having a +2 oxidation state. Here ammonia, there may be ammonia is a neutral ligand and there may be a formation of means which is having a the zero oxidation neutral which is there is no the oxidation state means the, here four the ligands and there may be having a +2. 4 + 2 means you can going to be there may be +2 is the charge on the copper means the where exactly the copper oxidation state is the +2, where +2 which can get neutralized with the +4. Then we can going to be seen the oxidation number of the copper is +2. And the coordination number, how we can going to be seen in the picture representation, the coordination, the zinc is bonded with the respective ammonia. Zinc is the metal ion. Here platinum is the metal ion. These are the ammonia ligands. Like here also cobalt, which can be bonded with the ammonia, and here also cobalt, which is having a the +3 oxidation state, and this is having a +2 oxidation state. And this number of these atoms, which can be the coordination number. And there may be the atom which can be going to be, means there may be a lone pair of electrons and metal ligand bond, which is nothing but the donor atom. Next we can move on to the IUPAC nomenclature of the coordination compounds. The IUPAC nomenclature of the coordination compounds, how we can going to be coordinate with the respective compounds, and how we can going to be made the rules for the naming the coordination compound. So in the first we can going to be seen order of the complex compound. Okay, the ligands are always written before the central metal ion, which can be naming the complex in the coordination complexes. And similarly the coordination, when coordination center is bound to more than one ligand, the names of the ligands are written in a alphabetical order, which is not affected by the numerical prefix that must be applied to the ligands. Means here, please bear in your mind, this is very very important. Suppose they are going to ask to name the respective coordination compounds. Okay, the ligands are always written before the central metal ion. Ligands which can going to be written before the central metal ion, means central metal ion which can be the first you can going to be written. Ligands are written first, and central metal ion you can going to be written afterwards. And similarly the coordination center is bound to be more than one ligand. The names can be, the ligands are written in the alphabetical order. Then we can going to be write the ligands in the alphabetical order, A, B, C, D, like this. Okay, and also numerical prefix must be applied to the ligands. Next point, when there may be a monodentate ligands which can be present in the coordination compound, the prefixes that can be inside into the respective ligands are of di, tri, tetra, and so on. Means based upon the monodentate ligands and bidentate and polydentate. Means there may be three types of ligands: the mono, which can having a single donor; bidentate, which can having a two donor atoms; polydentate, which can be more than two or more. That is polydentate. And coming to the fourth point, when there are many polydentate ligands which can be attached to the central metal ion, there may be the prefixes are the bis, tris, and so on. Bis means 2, we can going to call it as 2. Bis, tris means 3. Okay, and the names of the anions present in the coordination compounds must end with the letter O, which is generally letter which can be replaces with, means we can going to be called anion, means suppose S2 minus sulfato, and the chloride anion Cl minus, which can also be chlorido, and also fluorine, that is fluoro, and O2 minus oxido, and sulfate sulfato, and nitrito NO2 minus. Okay, means where exactly the negative ligands which can be ended with the O. And similarly, so the following neutral ligands which can be assigned specific names in the coordination compounds: amine, NH3, H2O, we can also be aqua, CO, carbonyl, NO, nitrosyl. These are all some of the neutral ligands. Okay, the neutral ligands which must be there may be the neutral ligands which is nothing but which can going to be zero means there is no there may be which consists of a the zero is the order we can going to be represented here, and the NO the nitrosyl. And similarly, ligands we can also be named in the name of the central metal atom is written in if the complex as a anionic charge means there may be a suffix which can be ended with the ate. Okay. Next, when writing the name of the central metallic atom, the anionic complex's priority is given to the Latin name metal if it exists with the exception of mercury. Means you can going to be central atomic in the anion, which can be a you can going to be priority is given to the Latin name of the metal. Means Latin name. Suppose they may going to be in the anionic complexes, the central metallic atom, which can be present. We can going to prefer that is the Latin name of the metal. Okay. Next, oxidation state of the central metal must be specified with the help of the Roman numerals that are enclosed in a set of parentheses. And the coordination compound accompanied by the counter ion, the cationic entity must be written in the ionic entity. Means these are all the some of the rules you can going to be the name the coordination compounds. Okay, and some of the examples you can going to be the you can going to be taken example and how we can going to name. Please bear in your mind these are the some of the standard rules which can must follow the nomenclature of the coordination compounds. Then coming to the applications of coordination compounds. Here the applications of the coordination compounds which can be in a wide range of the respective you can going to be used, and there may be the coordination compounds which can be extensively used in the industries for the coloration of materials, and there may be a fine application in the dye and pigment industries. And some of the complexes compounds containing a cyanide means in case of the electroplating, and also very useful in photography. And also we can going to be seen there may be in applications in the field of biology, and there may be the application field in the laboratory. Means here the some more there may be in the in case of biology there may be E complex ion which has a tetrapyrrole porphyrin ring structure with the central iron, and vitamin B12 consists of a tetrapyrrole porphyrin ring complex, and the cobalt ion which is nothing but which is having a coordination number 6 means the hemoglobin and vitamin B12 which can be used in case of the respective the applications. Coming to the in the laboratory, there may be a nickel DMG which can be estimated means the it can be estimated for the hardness of the water. Okay. In case of medicine, there may be cisplatin which can be used as a treatment for the cancer. In photography, there may be a can going to be used the developing the film in case of complex formation, and also in metallurgy we can going to use for the extraction of gold by silver by MacArthur Forest process. Involves a complex of cyanide ions. Okay, this is about means you can going to be seen the such a type of wide applications it can be observed in the coordination compounds. Okay, these are all the some of the applications of coordination compounds. Okay, this is about the coordination compounds. Okay, in the next lecture we are going to see about the coordination complex, and we can going to take the examples of the coordination complexes and how we can going to name the respective coordination compounds, and also we can going to study the different types of ligands. Okay, thank you.